Hello, everyone, and very good morning. Welcome you all to the webinar. And let me also very good morning and welcome you all to the webinar. I hope I'm audible to all of you. You can give me a confirmation quickly in chat box if the voice is audible properly. So very good morning, all, and welcome you all to the webinar. My name is Anshu Pandey. I'm going to be the instructor for this particular webinar, and let me introduce myself in a quick go. So I'm a Microsoft certified trainer as well. I hold few more certifications like I am a lead instructor from Wiley. I work as a data scientist and a data science consultant. Uh, I am a Microsoft certified data scientist and Microsoft certified Azure AI engineer as well. I work as a consultant for Ventures, which is a Silicon Valley company, and I mostly deal with a lot of businesses in telecom, banking, finance, and government organizations in the region of South Asia, Southeast Asia, and Middle East. So I have consulted many of the companies across Malaysia, Indonesia, uh, Middle East, UAE, and as well a lot of organizations from India. As a part of my job, I help businesses to build a data science team to move towards data science transformation or data driven transformation or AI transformation in general. I help them to design the right strategy and right path for AI movement. So yeah, that's about me. I have been working into the same field from last around 8 years and developing data science and AI applications for the same. So very good morning and welcome you all. That was about me. Many of you, maybe many of you might be working professionals. You might be working for any specific IT company, and many of you are college fresh graduates, or you work in you are already studying final year, third year of engineering, or maybe you are intermediate level school student. So this webinar is intended for those who all are interested to learn something about AI, for those who all are interested to know multiple terminologies, multiple terms, and how what's the meaning of those terms, right? And this webinar gives you it's going to give you very clear idea of terminologies like what is AI, machine learning, deep learning, data science, and natural language processing, computer vision. Many of these terms you will get more clear idea of at the end of this webinar. That's the main intention. I have a slight bad habit of speaking a little quick. So at any point, if you feel that I'm going quick and you want me to slow down or you want me to repeat anything again, feel free with that. Right? So feel free with asking me to repeat anything, asking me to explain anything in more clear way. For questions, I would strongly recommend if you have any questions, if you can keep it for the end of the session, that's wonderful. That's much better. Or else, I would recommend you to uh, keep only to the point questions in between. And if it is something irrelevant question, or maybe you think that this question is not related to the current topic, please limit your question, those kind of questions uh, for the end of the session. At the end of session, we'll spend good time, let's say 35 to 40 minutes, only for QA section, right? So if you do not put irrelevant question, we'll be able to go smoothly with the topics in a better manner, right? So otherwise, that may hamper or that may stop our flow. If it is relevant to the current topic, feel free to put that. Right? And I'm not limiting you with questions. You can ask any question of any type, right? So feel free with that. There's no limitation as such. So let's go ahead and get started, everyone. Okay. So we're going to be talking mostly about the idea of first AI, and in the first segment, that is in next 1 hour, I want you to. I'm going to help you out to understand. I'm going to help you out to understand what exactly is AI, and how of these multiple terminologies are related. So let's start with that. So talking about AI, which is internal artificial intelligence, uh, what do you mean exactly by, if you have a question that what do you exactly mean by AI or internal artificial intelligence? The answer would be artificial intelligence is a way of giving or providing intelligence to machines the way we humans have. So we humans have a capability called intelligence. So what is intelligence? The capability of humans to take intelligent decisions without following instructions from outside. So without following instructions from somebody else or outside the world, we take we make use of our own conscience, and using that we try to take intelligent decisions. That's what we call as AI, right? Or that's what we call as mainly intelligence. My bad. For example, let's say that nobody teaches us that use rule number one, rule number two, rule number three to recognize your friends and family members. We always remember our friends and family members, and we recognize them using their facial structure, right? We don't follow rules if the eyes are 2 centimeter wide or height, and eyes are 1 centimeter wider. The nose is 2 centimeter wider. It's my brother, or else it's my sister. We don't follow such rules. We remember the pattern, the facial pattern of our friends and family members. We remember the pattern of how do they speak for our friends and family members. Uh, is there anyone trying to use annotation? I would recommend to avoid that, right? That's causing a bit of annotation issue over here. Uh, right. Okay. So yeah, the idea of intelligence is more about taking intelligent decisions without following a fixed set of rules. Right? That's what we call as intelligence, or without following the rules fed by somebody else. For example, when we drive the car or we ride a bike, nobody tells us that, okay, do this, do this, do this, take step A, take step B. We all take our own decisions while riding a bike or driving a car based on our conscience. This capability of humans is called as intelligence. And when we give similar capability to machines or computers or software in general, we call it that as artificial intelligence. So providing similar capability or similar power to computers or machines is AI. For example, the way we humans can recognize our friends and family members, that's based on the facial structure. That's our intelligent capability. If I give similar capability to a software, we can call it as face recognition system. That's an AI application. The way we humans recognize our friends and family members from their voice, if we can give similar capability to a machine which can do speaker recognition, that's an AI solution. The way we humans can take our own decisions while riding bike or driving car without listening from somebody else, do this, we can take our own decision. Let a computer or software take its own decision while riding bike or driving car. That's an AI application. So in a nutshell, AI is more about making computers and machines act intelligently, much more like the way we humans act, or the way we humans capable are. So that's more of a nutshell idea of AI. In a nutshell, you can define that as it's more of the capability of humans, or sorry, capability of machines to imitate or to copy or to behave quite similarly the intelligent human behavior, right? So to copy or to imitate the intelligent human behavior, this capability of machines is what we term it as artificial intelligence. So that's the generic idea of AI, a logical definition, not more of technical definition, but a logical definition. Logical definition could be it's let the machines act intelligently. So how do we do that? It's very simple. We use the traditional computers or software. We add intelligence in the form of algorithms. So if you ask me what is the technical definition of AI, or if you ask me that, well, I understand that it's more about making computers intelligent, but how do you do that? So if you ask me how do you do this, is The answer would be AI is collection of, in general, AI is collection of algorithms. So there have been a lot of researchers who have been doing research across the world from last more than 5 decades. So AI is not something very new that is invented today. It has been into existence from last more than 50 years. And last more than 50 years, people in different part of the world have been doing different kind of research. Let's say somebody in China might be working on face recognition system. Compared to that, somebody in India might be working on computer vision application of text detection. Somebody in US might be working on using intelligent system for stock prices prediction. Somebody in Europe might be working on building a smart and powerful X-ray recognition system or tuberculosis recognition using AI. Right. So today, artificial intelligence is collective efforts of multiple researchers made by, efforts made by multiple researchers across the world. All of these people developed algorithms, and then they released that in research paper, and people programmed it and developed application. So today, AI is just collection of these all algorithms, bunch of these algorithms. As a part of studying AI or as a part of becoming AI engineer, if I have to become AI engineer, I need to learn many of these popular algorithms. How do they work and how do I use them? Once I learn them, then I can kind of say myself that I can now develop any standard AI application. So technically, the idea of AI is with traditional machines or computers or software, you feed intelligence in the form of algorithm, and that's what you call AI application. AI is simply uh, machines or computers plus intelligence. That's called AI. That's more of logical definition or technical definition of AI. Technical definition is it's a collection of algorithms which can be used to build intelligence or intelligent capability in machines. That was generic idea. Let's talk more about this, right? And we'll also try to discuss about how is it different or similar to machine learning. Next question is, how does an AI application looks like? So when it comes to visibility of an AI application or how does AI looks like is there's no AI's algorithm is not a hardware, right? It's just an algorithm which is a mathematical method can be programmed using a software. So an AI application is quite similar to a generic software or traditional software. For example, if I talk about a traditional software, that could be, let's say, a smartphone lock. So one of the lock system in smartphone is that you get an option of password in which you can enter a 4-digit password. You can enter a 4-digit password in a smartphone, and you get a keypad, right? So what we do is general is using this keypad, right, which could be a keypad of let's say 1 2 3 4 5 6 7 8 9. We press the password, and let's say that's our current password. Current password. In backend, what's going to happen in the backend software? It's going to compare if current password is equal to uh, correct password, then it's gonna simply say that true. That means you are allowed. Else, it's gonna say false. Right. So this is how this smartphone lock works out. We already stored a password. Whenever we enter a new password, if it is matching, then we are allowed to open the lock. Otherwise, lock will not open. Right. That's traditional software, and then you get the output. Finally, the output is like you are in or you are out. Right. So the output could be in or the output could be out. You are not allowed to open the lock. Right. So this is how traditional software looks like, which has certain input and certain output, right? So in a traditional software, you feed some input and you get some output, and the output is processed by a rule, if else rule, right? So this rule is the engine which is going to accept the input, do some processing, and generate the output, right? This rule is can be thought of as an engine which is accepting the input of current password, doing some processing, generating the output. This is not AI. This is not AI, right? So such software is not intelligent software. These are just rule-based software, instruction-based software, or a traditional way of programming or developing softwares. Then how does AI application looks like? So the same thing you might have observed that got updated with something called face lock. So today in Apple, we also have something called face lock, in which you enter your facial picture using camera. So using camera, you enter your current face. So if I enter my current face, a little bad at drawing, but yeah, let's say this is my current face. This is my current face. What's face app is going to do it? It's going to take current face. It's going to take current face and give it to an AI algorithm. An AI algorithm will give output match or mismatch. An AI solution will give output as whether the face is matching or mismatching. If it is matching, the output will be in. If it is mismatching, the output will be out. Right. So an AI application, quite similar to a traditional software, is also accepting some input, doing some processing, and generating some output. Right. An AI application, quite similar to a traditional software, is also accepting some input, doing some processing, and generating some output. And here, the only difference is the engine earlier, which was a if-else based rule, is now replaced by an AI algorithm. This engine, which was if-else rules, is now replaced by AI algorithm. Right? So an AI solution looks no different than a traditional software, right? So you can't develop AI applications without having idea of software engineering. That's also one of the things. And this idea gives you a generic understanding of that an AI solution or AI algorithm is not going to look any different. For example, the way we use AI in our daily life, right? So these are multiple ways we use AI in our daily life. We use Siri in Apple or Google Assistant in Android, which is an intelligent solution. We use in the form of software. We use Alexa, right? That's also in the form of software embedded in a hardware. Uh, or smart cars. Here is a software embedded in a hardware, which is like Tesla cars, intelligent cars, self-driving cars, or automated braking system in car as well as an example. Uh, Google Translate is again an Android app, right? So Google Translate, where we pass one language and it translates it to other language. Internet search that we do on Google, image search you do, text search you do, or video search you do, or face recognition system. Many of these are generic applications of AI that many of these applications we use almost every day, right? So yeah, that's more of idea, right? So these are a few generic applications of AI. Very good. Okay, so we have been almost using AI in a number of ways, right? So we almost use every AI every day. For example, you might be using Google Map for some reason, or Google Search for some reason, or if you're even using Gmail, in Gmail also there's an AI solution which automatically identifies the email is spam or not spam. That's also an application of AI. Whether you are talking about the Gmail solution, which automatically classifies your email as primary or social or update or uh, promotional, that is an also AI application. So these are few popular applications of AI. This is more of a generic idea of AI, a general understanding of AI that we wanted to give from these few slides. Now we'll move forward and we'll go ahead and look at the idea of data. Right. So next slide we try to understand is we'll try to understand the idea of data and what is data. Now this is a very important slide if you will, right? So the question is, what is data? So answer is anything which carries any information, right? Anything which carries any standard information is data. So for example, uh, anything which carries information, that could be a set of pictures, a set of videos, a set of audio files, or Excel sheet or CSV file or SQL database table. Anything which carries any information is data. Whether you talk about an Excel file having some uh, data of students, or Excel file having data of employees of a company, or customers of a company, or customers of a retail store. That's data. A set of tweets on Twitter is also data. A set of images on Instagram is also data. A set of videos on YouTube is also data. Anything which carries some information is data. Right. So there are two types of data: structured and unstructured. And let's understand that also. So structured data is something which something where you have data is stored in Excel sheet or CSV file. That's structured data. And whenever data is stored in the form of text or images or speech or audio, that's unstructured data. On structured data, you can easily execute a query. Right? You can easily run a query on structured data. Okay. So yeah, the idea is that in structured data, we generally can execute query, whereas in unstructured data, we cannot execute a query. That means structured data, I can write a filter and I can get a filter from structured data. But from unstructured data, we cannot do the filtering of data. So that means anything which carries information is data, and there are two forms of data: structured and unstructured. I hope you're good with this. Let me know, everyone, if you're good so far. Any question, doubt you have on this? Okay. So considering that you're good, let's go further, right? If you have any question, you can put that now, or you can put that later as well. You can make use of chat box for the same. So if we go, next slide is a very important slide. Next slide is the most important slide of the whole webinar today. This webinar is more of introductory webinar to give you a clear idea about multiple terminologies in general, and how many of the fields of AI are related and they work out. So that's where we're going to look at more of understanding of terminologies here. Right? So the next slide is very important slide. Is going to give you a very clear idea about how multiple terms or fields are related to each other. How let's say AI is related to machine learning and AI is related to deep learning. So here we go. Next slide, instead of writing, I'm going to actually be drawing that out, right? So that out here. Okay. So here we go, and let's understand the idea of multiple terminologies. And this is going to give you a complete idea of an AI stack. So this slide that makes, this makes this slide a very important one. Okay. So here we go. We discussed that AI is collection of algorithms, right? In general, artificial intelligence is a mere collection of algorithms, a number of algorithms, right? So I can define AI as artificial intelligence, define as collection of algorithms which can be used to build intelligence in machines. So AI is in general called as collection of algorithms which can be used to build standard level of intelligence in machines. Right. So that's more of generic definition of AI as per our previous discussion. It's more about a way of making computers and machines act intelligently. So a set of algorithms which can be used to build some sort of level of intelligence in machines. That's more of idea of AI. Now, that means in AI, there are variety of algorithms and there are multiple algorithms. Some of the algorithms are very powerful, some of them are less powerful. Uh, a set of most powerful algorithms in AI are part of machine learning. So you can say that under AI, they are slightly less powerful and then slightly more powerful algorithms. The algorithm which are the most powerful set of algorithms from AI are termed as machine learning algorithms. Machine learning. So machine learning is, again, you can think of this as a category of algorithms from AI which are more powerful. And what makes them more powerful or what makes them technically different is these are those algorithms which use data to build intelligence. So what makes it different is in AI you have variety of algorithms. Some of them do not use data and are not so powerful. Some of them which use data are the most powerful algorithms. So ML is a collection of those algorithms which use data to build intelligence. Right. So all of such algorithms which make use of data to build intelligence in or intelligent capability in machines, that's all of those are part of machine learning. So machine learning is always a subset of AI. So if you're doing AI, if you're doing machine learning, you can say that you're doing AI, right? You're doing machine learning, you can say that you're doing AI because ML is subset of AI. AI is a big umbrella of algorithms, and ML is a small umbrella inside that. Right? And what makes them different? So ML are those categories of algorithms which make use of data to build intelligence, or in any machines or software or computer in general. Right? So data is something which makes it important here, and it is a key thing over here. Uh, Data is something a key thing over here. The most important segment here, right, which makes it important in general, right? So yeah, that's more of idea. So today the question is why AI is so popular, why a lot of people are talking about AI and a lot of companies are moving towards AI. Universities, healthcare organizations, to uh, banking organizations, finance organizations, all of them are moving towards AI with a very faster speed. Why is that? One of the reason being the most powerful part of AI is ML, and ML needs data to build intelligence. And today, because of digitalization, because of almost every hand started having smartphones. If you look at 5 years in India, the Indian population, almost every hand started having smartphones in last 5 years. The wave of digitalization, almost every person has become digital. Almost every second person is using internet banking via some UPI method. Almost every second person is uh, booking cab online or ordering food or ordering products online. Right? This is making all the organizations in retail business, in finance, in banking, government, and many other solution providers, this makes it capable of them to be able to collect data from business. IoT at the same time makes manufacturing organizations capable of collecting data from business. So IoT, digitalization, increasing exponential growth of smartphones have made a lot of businesses being capable of capturing data. This has made governments capable of capturing data. For example, government organizations today have been using mobile apps for COVID-19, and using mobile apps, they are capturing data, and they have built a database platform. They are using AI and machine learning to fight with corona uh, and analyze data, track people as well. Right? So availability of data is one of the core reason why now everyone is talking about AI, and people are so positive and you can say very geared up to adapt AI based solutions. Available data is one of the main reason. Uh, Other is the availability of computational resources, right? Earlier also, if somebody was having data, the computational resources like the tools and technologies available were difficult and even expensive. The cost of RAM, the cost of hard disk, the cost of processor was expensive earlier if you look at 10 years back. And compared to that, now all of these costs have come to one sixth, even one tenth down, which has made low cost computational resource available to organizations. And that has also made it possible why now AI. So these are a few reasons why now people are talking about AI. And machine learning is one of the core reason in that. Right now, that's one more idea. Second is one of the other subset of machine learning is what we call as one of the other subset of machine learning is what we call as deep learning algorithms. One of the other subset of machine learning is what we call as deep learning algorithms. That's another category inside machine learning, which is deep learning algorithms. The most powerful part of AI today in the world is deep learning, the most powerful part of AI. And today, majority of the research happening in the world are happening in the field of deep learning. And so you can say that most powerful algorithms from AI are part of deep learning. Deep learning is a subset of ML. So as everything in ML uses data, you can say everything in DL also uses data. What makes deep learning algorithms different is you can say automated feature engineering. So what the meaning of this, we'll talk in more detail about what is the meaning of automated feature engineering. We'll talk about that in a while. But yeah, so the most powerful set of algorithms today in the world are deep learning algorithms, and they are so powerful that they can, if I have to show a few applications. So today, the self-driving car, the intelligent face recognition to speech translation system, right? So many of these intelligent systems are actually backed by deep learning algorithms. Right? And deep learning has even become so powerful. I mean, the development in deep learning has grown so faster that even there are videos or solutions developed which are not which are almost unbelievable. For example, if you look at this website here, the website is the person doesn't exist. So this website shows those faces which are generated or created by a deep learning algorithms, and these people are not real people. So these people do not exist in this world. These faces are generated by a deep learning algorithms. Right? These faces are generated by a deep learning algorithm, an AI solution. The algorithm is generative adversarial network developed by Ian Goodfellow. So these faces do not exist. They are not real humans. These are all the faces generated by AI solutions or a deep learning algorithm. So deep learning has reached to that level of efficiency, you can say, where it can generate fake faces or fake videos, or you can say even uh, uh, fake structures as well. So yeah, that's more of idea. So the most powerful part of AI is more of deep learning algorithms, and majority of the research today are happening in this field. And what makes us different, that's what we're going to see out, which is the technical idea. What makes us different from ML is the idea of automated feature engineering. Now, what do we mean by that? We'll get to see that out. Now, these are the three categories of algorithms: AI, machine learning, and deep learning. Okay. Now, when we talk about machine learning, we have said that, well, here the very important stuff is, or the very important concept is data, right? So data is a very important topic here. All of those algorithms which make use of data to build intelligence are most powerful one, or are part of ML. Now, when it comes to data, data is one of the very crucial part of any business process. A number of businesses have been using data. So it's not something that we use data only for ML or only for machine learning. A number of businesses have been using data even without advent of ML, even before, sorry, computers were developed, right? Even before computers were designed. So there is a field in which businesses have been analyzing and using data to take intelligent business decisions. And that field is called as analytics. For example, let's say that I have a shop in which I sell sanitizers, which I don't do. But yeah, let's say if I have a shop wherein I sell sanitizers. So what I do is every day I pen down that day one, it was 2nd of April, I sold 5 sanitizers. Day two, it was 3rd of April, I sold 20 sanitizers. Day three, I sold 6 sanitizers. Day four, I sold 2 sanitizers. I pen down the number of sales I'm making every day in my register, in my notebook. At the end of 1 month, I can check which week I made high sales and which week I made low sales. At the end of 3 months, I can analyze. Generally, in first week of month, I'm making high sales. Last week of month, high sales. Middle 2 week of months, I'm making low sales. So if I have to take an off, if I have to go for a tour, I'll go with I'll go for which particular week. So you can say that I'll go for 2nd or 3rd week, because usually I have observed in 2nd and 3rd week of month I make low sales, right? So this is about capturing data even in register at the end of the day, looking at average sales every week and then taking decision. This is what we call as analytics. So data analytics is also a field which uses data, and it is not machine learning, right? So data analytics is not machine learning, right? And so that's not machine learning at all. And you can say it's more about using data and applying statistics like average, mean, median, mode, statistics, and data visualization. So data analytics is about applying statistics and data visualization on structured business data and using that for helping business to understand uh, or to take better business decisions. So that's what we call as a field of data analytics. In analytics, mostly we consider using structured data, right? So the type of data that we deal with in analytics is always structured data. As we discussed, there are two types of data: structured and unstructured. So the format of data here we use is structured data. Let me give you an example, right? So hold on for a moment. I can give an example. So structured data is like a data which is stored in general, let's say in a CSV sheet or in an Excel file. That's what we call as more of a structured data. So let's say that in case if you have a data of let's say we have data from a bank, right? So let me open the data set here. Then you can maybe we can look at that. So here, let us say that we have data from a bank, and the bank has given us data of 10,000 customers of it, right? So there is a bank, and the bank has given us data of, you can see, from 1 to 10,000 customers data we are given with. So we have data of around 10,000 customers of a bank. For every customer, the bank has given us data, right? The bank has data of row number, that means the sequence number 1, 2, 3, 4, like that. That's a row number. And then we have customer ID. The other attribute is what we have is customer ID. And then let's say that we have, for every customer, we have surname of the customer. So whatever is the surname of customer, that we have as a part of our data. And then we have credit score. Credit score in India is like CIBIL score. We call it CIBIL score in India. Credit score is a European term which is used to calculate credit worthiness of every customer in a bank. The bank has given data of geography, where the customer is from. Customer is from France or Spain or Germany. Gender of the customer as well. Age of the customer, how many years the customer is old. Tenure, how many years the customer is associated with the bank. So 2 years, 1 year, 8 years. Balance, we have balance reported in the minimum balance reported in customer's account. right? And Suhan, so we can talk about analytics again. So the same thing we are talking about it, right? So let's take this business case, and this business case is going to help you all to understand what is data analytics. This case that I'm explaining, the example that I'm explaining, is going to help you out to understand very clear idea of what you do as a data analyst. So we have number of products for every customer, right? So one customer has one product. That means this customer has only a savings bank account. Three means this customer might have a savings bank account plus insurance or a mortgage loan, home loan or vehicle loan, anything like that. This column shows customer has credit card or not. So one means yes credit card, zero means no credit card, yes credit card, no credit card, like that. This column shows is it the customer an active member? That means has the customer been doing uh, actively using the bank account? Let's say if I don't use my bank account, I use only one time in 6 months, I'm not an active member. So zero, not active member. One means yes, active member. Then we have salary of customer. The bank never knows the exact salary. So based on regular deposit, bank has estimated the salary. And then finally we have whether the customer left the bank or not. Now this is a very important column, everyone. The bank observed that in last 6 months, a number of customers started leaving them. They are worried about that. They observed in last 6 months, a number of customers started leaving the bank. They started closing the bank account. And they are very worried about that. They are very concerned about that, right? So the issue with them is that why a lot of customers are actually leaving them, right? So this is one of the concern for them. So they are worried that why a lot of customers are leaving the bank. Now, because of this concern, they are, they are very in a huge problem. And what they want is they want to understand why customers are leaving us. What are the possible reasons customers are closing their bank account? They're very concerned about that. So as a data analyst, what is my job is I need to take this data, perform some analytics on it, perform some statistics and visualization, and give answer to the bank that, well, these are the reasons or possible reasons why customers are leaving the bank. So as a data analyst, what you do is a data analyst job is to answer why this happened in the business, why sales went down, why profit went up, why customers have started leaving, why people are not buying product, why people are getting corona, right? These are all stuff what an analytics does. And analytics answers the question why this happened. So let's say government of India might come up and say that why in Maharashtra a lot of people get corona pandemic, right? So it spreads faster. What was the reason, right? So an analyst is going to look at the data and analyze some angles and going to look at that connections, and we're going to say that, well, this could be possible reasons for that, right? Or let's say why corona spread in China, or why it came to Italy or Iran, right? So an analyst can look at the data of all the people who got infected and can make some sense out of that, create clusters, analyze them, connect them, and then say that, well, this could be possible reasons why this happened. For example, here, if I have to act as a data analyst and I have to answer, a lot of people left the bank. So you see here, this column says that those customer left the bank. So one means this customer left, and zero means this customer did not leave. One means this customer left the bank, and zero means this customer didn't leave the bank. Left the bank, didn't leave the bank. Left the bank, didn't leave the bank. So if we have to answer the question, why customers are leaving the bank, if we have to answer that question, how will we take it as? So we can compare this with any of the feature. Let's say the feature is age, right? So we can compare this and do some statistics on this, right? So let's say kind of statistics I can do is, if I calculate average, average is what? Mean. Average age of customers who left the bank, if that is, let's say 65 years, and average age of customers who did not leave the bank, if that turns out to be, let's say 36 years. Now, can we say that majority of the customers who left the bank, is their age higher or their age lower? Majority of the people who left the bank, were they age higher or they were age was lower? Were they old age or young age customers? Measured based on this statistics, if you look at average age of all of these people, those people who left the bank is 65. Average age of those who did not leave is 36. So what do you think based on the statistics? Majority of the people who left the bank, were they old age people or young age people? So this is a question you can answer in the chat box. The question is that if average age of customers who left the bank is 65, which is higher, average age of people who did not leave the bank, who are still in the bank and who stayed, who had not closed their bank account, is 36. Their average is 36. So what do you, by comparing both the means or comparing both the values, what do you think? Average, most of the customers who left the bank were old age or young age? So you might say that, well, looks like most of the customers who left the bank were old age customers. That means as an analyst, I can tell the bank, looks like you do not have offers or services which meets financial goals of old age customers. Looks like old age customers might have different financial goals. Old age customers might be looking for insurance or something else, and you may not have those services. That's the reason old age customers are more leaving the bank. So as an analyst, you look at the data, you perform statistics, and you answer the question why this happened, why people are leaving the bank, why people are, why your sales are going down, why you are making more losses, why your assets are not being used, right? Or why, the company is getting down, right? Why machines are getting damaged. You answer these all kind of questions as an analyst, according to which business you're dealing with, right? So the job of analyst is to deal with structured data, apply statistics and data visualization on it, and use Python as a tool or R programming as a tool to do this kind of stuff. The combined idea of, I hope we are all good with the understanding of what is data analytics and what do you do as a part of analytics. Then the combined idea of data analytics plus machine learning is what we call as data science. So now let's say that, this is what we call as data science. Now, why do you need machine learning in this case? Let's see that. This is very interesting and important, everyone, right? Now let's say the bank, excuse me. Now let's say that as an analyst, I have answered the question why customers were leaving. Now the bank might work out on that and bring some reforms in their policies to make customers not leave and to retain more customers. But then bank also is worried that in future a lot of customers will leave them. So bank also wants to have a solution which can predict out of existing customer. The solution should be able to predict the future. In future, how many customers will leave the bank? So in next month, which of the customers are more likely to leave the bank? If we have to predict that. So out of, let's say, 1 million customers, if I have to predict which of the customers are going to leave. So bank wants to now predict future, what will happen in future. Now, whenever you want to get answer to the question, what will happen in future, that's where you can use machine learning. So on the same data, I can use machine learning and I can develop a solution to answer the question, what will happen in future? Right? I can use this data and feed it to a machine learning algorithm. It will learn from that. And for any new customer, it will be able to predict whether that customer will leave or will not leave the bank. So using data and building a business solution to answer the question, what will happen in future, that's called as machine learning. And the combined field in which you do both of stuff is data science. So then the bank may go to a data scientist who can take their data and build a predictive solution out of it, which can predict the future. So data science is a field which uses data. It's composed of analytics plus machine learning and deep learning in general. So I hope this gives you quite clear idea about it. All right. Okay. Then we have, in data science, we mostly talk about the type of data as only structured data. Right. So the type of data here we deal with is only structured data. Structured data in the sense Excel sheet, CSV file, SQL database tables, only structured data. No images, no video, no text, no audio. Right? This we don't talk about, which is unstructured. Quite similar to data analytics, there is a field which we call it as, quite similar to data analytics, there is a field which we call it as image processing. So there is a similar field to data analytics, which we call it as image processing. So image processing is a field in which again, image processing is not machine learning. We do not use machine learning in image processing. We do not use AI in image processing. It's very simple programming, applying linear algebra and programming techniques on images and videos. So image processing is a field in which we deal with data which is in the form of images or videos, video without audio, right? So video also without audio. So field in which we deal with images and videos, perform some pre-processing on that. For example, I have a lot of images. I can resize them all of the same size. I can crop the image, I can resize, I can increase the brightness, decrease the brightness. If image is blurred, I can make it more clear. If image is having a lot of white component, I can reduce it. If image is dark, I can make it brighter. Many of these techniques are done as a part of image processing, right? So the field in which we deal with images, videos, and perform basic processing of them, to make images more informative or to extract information out of it, that's what we call as image processing. The combined field in which after doing image processing, you want to feed those images to a machine learning or deep learning solution, the combined field is called as computer vision. So in computer vision, we take images and videos and develop intelligent system. For example, I have data of faces of my employees in a company. I can take 5 pictures of every employee, and such 20 employees, I can take 100 pictures in total and feed it to a machine learning algorithm to develop a face recognition system. So face recognition system, emotion detection, happy or sad, emotion detection system, or uh, traffic sign detection, text detection, object detection. Many of these are examples of computer vision. So the combined field in which we use image processing plus machine learning and deep learning algorithm, the combined field is called as computer vision. The computer vision is also a field which uses machine learning. Data science is also a field which uses machine learning. Data science applies machine learning on structured data, whereas computer vision applies machine learning on, in computer vision, we apply machine learning on images and videos, video without audio. The combined field, quite similar to this third field in which we deal with last form of data, which is text and audio. So that field we call it as text or audio processing. So we call it as text or audio processing. So this field is called as text processing or audio processing. And the combined field, like I might have data of a lot of tweets on Twitter. I want to do social media mining. I have data of audio. I want to do audio classification, speech to text, text to speech conversion. I want to develop a chatbot, many such applications. So the combined field in which we deal with text and then we apply machine learning on the top of it, that field is called as natural language processing. That field is called as more of natural language processing. It also uses deep learning as well, right? I'm just because of some scarcity of space, I'm trying like this. So that combined field is called as NLP, or in general, natural language processing. So NLP is a field in which, let's say, I can do text classification, I can develop a chatbot, I can develop a speech to text, text to speech conversion system, language translation, sentiment analysis. These are all scenarios in which we use data in the form of text or audio. So the field in which we process data in the form of text or audio is NLP. And we apply ML and DL and AI on that. So artificial intelligence, machine learning, and deep learning are just categories of algorithms. AI, ML, and deep learning are just categories of algorithms. How industry uses AI or ML or deep learning? So industry uses AI with the field of data science, computer vision, or NLP. So in industry, when you apply for job, if you are a fresher or you are into college, or if you are already IT professional and you're looking to shift, you may not find a job with AI engineer a lot. There are very few jobs with AI engineer names or the name of machine learning researcher or engineer or deep learning engineer. Majority of the jobs will have name like data scientist, data analyst, uh, computer vision engineer, NLP engineer. So the way industry uses AI, machine learning, or deep learning in real world are the three fields: data science, computer vision, and NLP. These are the three ways how an industry uses AI in general. So this is the complete landscape of AI, right? Which of the fields use AI and which of the fields are related to AI and how are they related to AI? So yeah, let me know any question, any doubt you have on this. Other than the idea of ML versus deep learning, any question, any doubt you have in this, please let me know on this slide. A quick analysis of questions. Any question, doubt you have on the current slide of this AI landscape discussion, let me know. We are not done, right? We are yet to continue further. Okay. I believe we are good. I believe all of us are good, right? Uh, Saksham, you have missed something, but I believe we will be uploading the video of this webinar as well on YouTube, for which we will be sharing a link. So I would recommend you to watch that again. Okay, great. So here we go, everyone. And this was more of idea of AI, machine learning, deep learning, NLP, data science, and computer vision. So this slide was to make you understanding of concepts, understanding of terminologies, how different terms are related to each other, how different fields are related to each other, make that quite clear. So that whenever you talk to somebody who is working in the field of AI, you don't feel unknown, you don't feel uninformed, right? So you should have idea of many of these terminologies in general. So that's one idea. Now, there's a question about what is this stuff called automated feature engineering, or how ML is important than DL, how deep learning is important compared to ML, or how deep learning is more powerful compared to machine learning. Right. So let's get answer to that question, and this is very important concept. Okay, here we go. Maybe you see at this point we are discussing a lot of stuff. Many of these things for some of you might be basic, for some of you might be very advanced. If you feel that this is something that I don't make sense out of it, don't need to worry about that. uh, you know if you're a beginner, if you practice a lot, or maybe if you get into the field and study more, you will get understanding of terminologies. But yes, it's very important that you get structured idea of it and you get a right idea of it. Yeah, that's more of idea. Okay, now yeah, coming back to this case study that we discussed out. So we discussed that we have data of 10,000 customers of a bank. For every customer, we have row number, customer ID of the customer, surname of the customer, credit score of the customer, geography, where the customer is from, gender, the customer is male or female, age of the customer, tenure of the customer, how many years the customer is associated with the bank, the minimum balance reported in the customer's bank account, number of products, credit card customer has or not, then the customer is actively using bank account or not, salary of the customer. And finally, the last column shows whether the customer left the bank or the customer didn't leave the bank. Right, so that we have. Now, if you have these attributes, if I have to use this data and feed it to ML algorithm, feed it to a machine learning algorithm, if I have to use this data and feed it to a machine learning algorithm, so what do you think? Which of the data or which of the attribute I may not want to feed, or which of the things or which of the attributes here are not relevant whether the customer will leave or will not leave? Out of column A to M, which of the columns has no relation at all to the column N, and you think that these columns or this column may not have any relation whether the customer will leave or will not leave, and given that I should not feed this data to a ML algorithm. So which of the columns or column you think I should not feed it to a machine learning algorithm in general? Right. So which of the column or columns you think that I should not feed it to ML algorithm? You think that this column doesn't impact anyways whether the customer will leave or will not leave, right? And you think that this has no relation with that. Okay. So there's one answer which is gender. No, gender may have. It may be possible. We are not sure, but it may be possible. Males and female customers may have different financial goals, right? So male and female customers may have different financial goals, and bank may not have relevant services to meet their financial goals. Tenure may be again important way. Tenure shows how many years it's been the customer is associated with the bank. So if a customer is associated from last 1 year, that means those are new customers. And if the customer is associated from last 5 to 6 years, those are old customers. Old customers may have lesser chances of leaving. New customers may have higher chances of leaving, possibly. We are not sure about that. It just that could be a possibility. So you can't guarantee that these are not important. The question is which feature you think is you can guarantee and you're very sure that this is not at all important and has no relation whether the customer is going to leave or not. So there's an answer from Gautam that is A, B, C, and E. Well, E could be important, Gautam. Geography, if you talk about that, France, Germany, Spain, where the customer is from. In different country, there might be different competitor bank, different service set of services from competitor banks as well. Different economic policies of government. Maybe in one country there could be economic slowdown as well, possibly, right? So it could be, it maybe, it may not be geography. So at least can we say everyone for column A, do you think row number has anything to do with whether customer will leave or not leave? Is it an important column? Is it row number has any relation whether the customer will leave or not leave? It has not any relation. Customer ID. Customer ID is just an identifier to identify customer. Let's say Aadhaar card number. Does it have any relation whether customer will leave the bank or will not leave the bank? It has not. Surname of the customer, does it have any relation? No as well. So these three columns has no relation. We know that logically that these three columns has no relation whether customer will leave or will not leave. For rest of them, we are not sure. So what we do is for rest of them, what I can do is I can go for credit score, let's say. And what I can do is I can simply calculate average credit score of customers who left is 650 and average credit score of customers who did not leave is, let's say, 649. So can I say both the credit score are almost approximately equal? Now average credit score of people who left the bank is 650 and who did not leave is 649, which are approximately equal. That means the behavior of people who are leaving and not leaving with respect to credit score is same. That means credit score has no information, is not able to tell us that high credit score people are leaving, no low are not leaving. Anything pattern like that doesn't exist, right? So credit score doesn't impact, you can say. As the average credit score of people who are leaving and not leaving is almost same. That means those who are leaving are on the same level of credit score. Those who are not leaving are also on the same level of credit score. So credit score has no information to say who is leaving or who is not leaving, right? So credit score is not impacting factor. Like that, ABC we rejected based on our domain understanding. D we can reject based on statistics, possibly if this is the statistics. Similarly, from the whole data, we have to statistically verify whether every feature is important or not. This process of statistical verification is called as feature engineering. In the industries that I have worked so far, and the projects that I have done, based on that, almost 70 to 80% of time, every company and every project you spend doing feature engineering. That's a very important part of it. So let's say feature engineering is what? If I think column A, B, C are not important, I want to remove them. Right? What if I don't remove them? Let's say if I don't remove A, B, C, what will happen? Let's say if there are some customers who are having surname as Pandey, like me, right? So they are having surname as Pandey. What's going to happen is the algorithm is going to learn that those people who are having surname Pandey are more likely to leave the bank, right? If some of them have surname Pandey are leaving the bank, the algorithm will learn a pattern that those people who have surname Pandey will leave the bank. For all of the existing customers, if the bank makes use of that algorithm and does prediction, the algorithm will predict that, okay, X Pandey, B, Y Pandey, Z Pandey, these people will leave the bank. The bank might end up providing some offers to those customers. So the idea is that if I feed wrong data, algorithm will learn wrong pattern. If it learns wrong pattern, that will lead to loss to the client. So the overall performance of the machine learning application heavily depends on the quality of data that you feed. For example, if I develop a face recognition system, the images that I feed, all of the faces are like this. All of the faces are side-facing faces. If I send this kind of picture, feed this kind of picture to a machine learning algorithm, this picture, will it be able to recognize this face? You can say that this picture, if I feed this picture to algorithm, it will not be able to recognize this part of the face, right? Because this picture is not right data. It's very inqualitative data, right? Or maybe this picture is not right data. It's very inqualitative data. Okay. So the overall performance of any machine learning solution, whether it is face recognition or data science or NLP or computer vision, heavily depends on quality of data. The process in which we get more qualitative data and identify more qualitative data is called as feature engineering. Now, doing this process is easier when you're dealing with structured data. Let's say if I remove these three columns, can I say that unwanted data will be removed for all the customers? Unwanted data will be removed for all the customers. Row number, credit score, and surname. These three are unwanted columns will be removed for all the customers if I remove these three columns, right? For every customer, all the three unwanted columns will be removed. So when you have structured data, it is quite easier to do feature engineering. You just delete the column which you don't need and you're done. You just delete the column which you don't need and you're done. You're done for a whole data. So doing feature engineering becomes easy. But if you do it with unstructured data, it becomes very difficult. Let's take an example. Let's say I have images of lion and I'm doing a machine learning application of detecting lion versus human. In case of lion versus human, I have to tell a machine learning algorithm that in this picture, this part of the image is not important to recognize lion. I have to tell algorithm this part of the image is not important to recognize lion, and it is very difficult to crop the image and tell that only this part of the image is important. And for every other image, I will have to use different method, right? For example, for this image, I will have to use, I'll have to say differently that in this image there is another part which is not important, right? There is another part which is not important, you can say, and this image, this part is not important, right? This part is not important. In any other image, for example, this image or any other image, I will have to say different other part is not important, or maybe let's say this one, I'll have to say that this part is not important. So in every image, you will have to do it separately. It's not something you remove a column and the column is removed for all the customers. In case of structured data, the idea is what? You remove one column and unwanted data is removed for every customer, right? I'm sorry. In structured data, the idea is that here, if you look at this data, if I remove these three columns, unwanted data is removed for every column. But for images, I will have to do it separately for every image. So the process of feature engineering becomes very expensive, and it becomes very difficult to do for unstructured data. For structured data, it is easy, right? So for structured data, feature engineering becomes easy, and for unstructured data, it becomes difficult. So the idea of deep learning, here it's the deep learning comes into picture. The idea of deep learning versus machine learning is, in machine learning algorithm, you have to do manual feature engineering. That means you have to manually tell what is important, what is not important, and remove that. But in deep learning, the algorithm does this automatically. The algorithm does this process of feature engineering automatically. We don't have to tell the algorithm what is important, what is not important. The algorithm will itself identify which column is important and which column is not important. It will do statistics, it will do everything to identify that. That makes deep learning algorithm more powerful. If I feed this image to a machine learning algorithm will also learn that this is important until unless I mention that. But a deep learning algorithm will automatically learn that this is background and this is only the lion. A deep learning algorithm will automatically learn that white color is background, only this color is lion. To a deep learning algorithm, I don't need to tell what is background, what is not, and what is not background, what is lion. It automatically learns that. This capability of doing automated feature engineering is what makes a deep learning algorithm more powerful. Right? So that's the main idea of difference between machine learning versus deep learning. This completes the complete landscape of AI in general. Let me know if this is clear, everyone. Any question that you have in this landscape of AI? Or AI stack, you can say. I hope you're good. I hope you are good. Here we go. Let's go further. Next thing that we can talk about is now the idea of machine learning, right? So we can talk about the idea of what is machine learning and how does that works out. Okay, so here we go. Or before that, I have to take you through sort of examples. So we discussed that, well, the three categories of algorithms are AI, machine learning, and deep learning. And the way you use them in industry are data science, NLP, and image computer vision. NLP is about making use of text and audio. On the top of it, you build applications related to, on the top of it, you apply a machine learning and build applications related to text and audio. Let's take more examples to understand three of them in more detail: data science, computer vision, and NLP. So the three fields which uses AI in general are data science, computer vision, and NLP. These are the three fields which use AI in general. Now let's talk about them and understand one by one. If you talk about data science in general, data science is a field wherein we make use of structured data, and on structured data we apply machine learning and deep learning algorithms. The examples of applications could be, you can say, the scenarios in which you develop a model to predict the stock prices, predicting housing prices, predicting item prices, anything like that. And similarly, predicting prices of any other item, that could be also example of data science application. Develop a model to predict whether customer will leave or will not leave, customer will buy or will not buy the product. And similarly, you can say classifying customers into different known groups or known buckets. Let's say identifying customer who will buy product A or product B or product C. Anomaly detection from transactional data, credit card fraud detection, identifying any anomalous transaction, segmentation of customers, stock, and servers are examples of data science. For example, if I have to show you a live example of data science in general, could be, so if I take you to India COVID, or let's say COVID-19 India.org. So this is in a data science applications, and this platform is something which gives you a data science structure or idea of structured data, and based on that, it gives the idea of COVID-19. So this is a data visualization platform. I can go to any state and look at the idea of that particular state and how many COVID-19 positive cases are identified out of that. This is an example of structured data. In every state, I can look at the confirmed cases and all. More than that, where is machine learning? So this is not machine learning. This is just data visualization and data representation. Here is an example of machine learning applied on the top of same data, which arranges the data in clusters format, right? So this shows the cluster of all the COVID-19 patients in India, right? So how many patients got connected to how many patients, and those are being tracked. All the individual dots are patients who are isolated, and they are kept in quarantine, right? So if I scroll down, or if I zoom out this one, so I can click on any of the patient and get the details of that. So let's say this patient P659. So this patient P659 is a female from Maharashtra, Mumbai, hospitalized, reported on 26th of March. So these are all individual patients who got quarantine, who got corona for some reason. Maybe they are travelers or something. Then it has also arranged, a machine learning algorithm has arranged those people who are tracked out. So P95 has caused corona or COVID-19 because of this person got 2% infected, P122 and P123. Maybe they are family members. P389 is causing to, P389 is a person from Uttar Pradesh, Greater Noida, and reported on 22 of March, male, 37 age. Right, and you can look at this is a big cluster, so there are a lot of people who got infected from this. right? So which are, there was certain event which caused this a disruption, and then this is another event which caused this disruption, right? There are a lot of people who connected to that. Then there are a lot of people who are, causing disruption or infections to each other. So this is an example of representing data. So you can say that here, uh, this person got, these are different small clusters. So this person has caused it to different other uh, levels. So this is more of arranging data, and also it is representing data in a way so that people who are deceased or hospitalized or recovered are being also shown here. Okay, so yeah, that's one of the idea. Okay, so this is one of the platform which uses data science, you can see in general. And so segmenting customers or data or pointers into different groups. Predicting patient readmission. If a patient has come to hospital, whether patient will come back to the hospital or not, predicting that is an example of data science. Detecting anomalies or suspicious behavior from data. That's also data science. Recommendation system, like product recommendation on Amazon, movie recommendation on Netflix, to video recommendation on YouTube, are different examples of data science. So these are all data science examples. In data science, generally, you talk about structured data, you apply statistics, you do manual feature engineering, and you make use of machine learning and deep learning algorithms as well. There's less of deep learning that we use in data science. Second is computer vision. Computer vision is a field wherein you apply machine learning and deep learning on the top of images. Examples could be, let's say, face recognition system, right? So recognizing different human faces, to emotion detection, right? Detecting emotion, whether the human is happy or sad, happy or sad. For example, if I have to give an example, uh, I can give an example over here. Uh, so there's a platform which is called Teachable Machine Learning, right? I can show you a quick example of developing a quick machine learning application over here. So here we teach a machine learning algorithm using, let's say, neural network is an algorithm, and we teach machine learning algorithm using uh, images and videos, right? So we can try out here images and videos and teach a machine learning algorithm using that. So let's start with that. Let's take an example over here. Let's say I want to do an image project, right? And I want to recognize two kind of things, which is like a happy face versus a sad face. So I have to recognize a happy face versus a sad face. Uh, okay. So let's say I'm going to make use of webcam, allow. Oh, the webcam is not accessible because my webcam is accessible by this. I'm going to stop this out and I'm going to make another try. Yes, so I'm going to record it, right? So I'm going to report happy faces. So I'm going to name this as happy. Okay. And let's see. I have to smile. It is recording all the images which are happy faces. You can see that we got all the images recorded of happy faces. Okay, so here we got happy faces. Now, once we have happy faces images, next we have to record images for sad faces. Okay, and this is sad. Okay. So we are, you see, this is nothing but data. These all images are data. These are all hundreds of images we have collected. The hundreds of images in which I'm happy are data. And using this data, we're gonna be able to train a machine learning algorithm, which can learn how a happy face looks like and how a sad face looks like. So I have to now act a sad face. So 211 images I captured for sad face, 244 for happy faces. Let me capture a few more images for sad. Okay. Now I can go ahead and train the model using machine learning algorithm. So I have picked one of the algorithm, which is neural network, and using that I can train the model, right? Let's go ahead and train the model. So the machine learning algorithm is going to learn from happy faces and sad faces, and for any new picture, it's going to be able to predict whether that face is happy or sad. It's training the model, as you can see that. So this is an example of computer vision. Computer vision is more of classifying images as face recognition, emotion detection, to object detection. These are a variety of applications of computer vision. Identifying objects like which are unwanted on airport, they use that. Facial parameter mapping to land detection in self-driving car, traffic sign classification in self-driving cars are a variety of examples of applications of computer vision. The model is getting trained out of 50 iterations. It has completed around 25 iterations. And let's see further. Once it is trained, then we can use a trained model. It's going to be able to learn from the data how a happy face versus how a sad face looks like. Okay, so let's see that out here. Right, so it's going to make prediction for a happy face. And then I have to say sad face. It's a bit confused. Now you can see the probability of sad is high in general. Right, so that's an example of object detection, or you can see motion recognition in general. Right, so that's an idea. Okay, so yeah. Computer vision is more about using images and videos, and based on that, building the applications on the top of it. Other applications of computer vision could be optical character recognition, recognizing characters, which could be, handwritten text. So from handwritten text, identifying the characters. That's also an application of computer vision. Then document verification, verifying a passport or Aadhaar card is real or not real. Right? Object identification and classification as well. So in an image, there are different objects, identifying which are those objects. Forgery, if somebody is doing Photoshop on the image, identifying that whether the image is forged or it is compromised or not. Uh, Other example could be vehicle number plate detection, type detection, self-driving car, lane detection, traffic sign classification are different applications of computer vision in which we process images. Motion detection from video, if image is blurred or it's not clear, restoring the image. Pattern transfer, predicting action, if a car is going straight and taking slightly left, which turn the car is going to take, predicting that as well. So these are all examples of applications of ML, AI, and deep learning on the top of images, and which all fall under the field of computer vision. So this question about explaining a bit about deploying ML models on AWS. We'll talk about that. Just let me finish the slide. So this is where we're talking about everyone the idea of NLP. So NLP is more about using ML or deep learning algorithms on the top of text data. Right? So text or audio data. So here we develop applications like text classification or document classification, social media analytics. Right. So like capturing a lot of tweets from Twitter and performing some analytics on that. Right. That's also an example of that. So to look at, let's say, popularity level of a person or maybe a brand, right? So brand analysis as well. These are different examples of applications of ML and deep learning on the top of text data. Similarly, the other applications include speech to text, text to speech conversion. Right. The other applications include text to speech and speech to text, text to speech conversion, which chatbot creation, creating chatbot, analyzing text, right? Performing sentiment analysis on the top of text, identifying let's say feedbacks which are positive or negative, right? Speech recognition or speaker recognition as well, personal assistance, text generation, topic modeling are different applications of NLP, right? So these are all the scenarios in which we make use of text, the data in the form of text or audio, and on the top of it we apply machine learning or deep learning, right? So That's main idea. Okay. And yeah, so these are few popular applications of, you can say, NLP. Going further, this was more of idea about the overview of AI, machine learning, and deep learning. So we wanted to take one more. We'll have one more webinar in which we'll talk about more about deeper idea of deep learning and machine learning as well, and with few examples. So this was complete idea, which kind of gives you a overall idea of what is AI, what is machine learning, what is deep learning, everyone. And yeah, in general, if I talk about how do I learn AI or machine learning or deep learning, so if I talk about the programming languages in general, which are used for developing applications or of ML or deep learning, so there are two popular programming languages to develop whether data science or NLP or computer vision applications, which includes Python and R programming. Python is one of the most popular programming language, and R is as well. R is very widely used for statistics. So those who are statisticians or academicians or researchers, they prefer using R. Those who work with, let's say, field of deep learning and use deep learning for computer vision and NLP, they prefer using Python more than R. In general, both have same capability, quite similar capability, but Python becomes king when it comes to deep learning applications compared to R. So Python is more popular than R, and second most popular language would be R programming. But as a programmer or as a developer, you need not to learn both of them. You can pick one of the language and go further with that. Other than these programming platforms, there are a couple of cloud platforms as well. For example, Microsoft has Microsoft Azure Machine Learning Studio. AWS has AWS SageMaker, AWS Machine Learning platform, and SAP has Leonardo plugins. GCP has Google ML platforms, and similarly, IBM has IBM Machine Learning platforms as well. These are popular cloud platforms which are used for developing and designing ML applications. Right, so these are popular tools. Now, what to learn in machine learning or deep learning? If I have to become a machine learning engineer or deep learning engineer, what should I learn? The standard idea is that you need to learn a bit of idea of Python programming or R programming in general. So programming is one of the techniques that you need to learn, but only 30% part of it is programming, and around 70% part is mathematics. When I say mathematics, don't get scared about it. Here, it's not core academic mathematics, but it is more of applied mathematics. So when I say applied mathematics, you just need to know application of how to do that. So you need not to go through equations and derivations and all of it. You need to know applications of how to use this mathematics. For example, you need not to remember the formula of variance, but you need to remember how to use variance and when to apply variance, when to use mean, median, mode, and when not to use it. So more of applied mathematics, you need to have idea for implementing a machine learning solution. You can design your journey of learning ML or learning to become a data scientist or ML engineer in this way. You can focus first on Python for learning Python for machine learning. Here you learn basics of Python and packages used in Python for developing ML solutions and analyzing data. You learn a bit of statistics that can help you out to become a data analyst. And once you become data analyst, you can answer the question why this happened in past. Then you can focus on some machine learning algorithms. These algorithms can help you to understand how predictive modeling works. You can implement them fourth step using some Python packages. Once you are able to implement an end-to-end predictive solution, you should spend a lot of time on practicing as much as practice multiple examples from different platforms, use cases, participate in competitions, hackathons, and a lot of them. This builds your overall competency on ML solutions and gives you a 360-degree idea about how an ML solution can be developed. But still, you cannot develop at this level. You cannot develop a solution of production grade where a company can spend money on that and deploy it to production. That's where you need to learn optimization and boosting techniques. This is where you optimize the model not only in terms of accuracy but also in terms of size and the speed of production prediction as well, to make it optimum so that it could be deployed in a production environment. It could be used in business. It can generate money out of it. At the end, it may or may not be required for you, but just an option to learn how to handle big data using the tools like Apache Spark or Hadoop Yarn or maybe any other big data tool. This could be a possible journey to become a data scientist or a machine learning engineer in general. So yeah, that's all about it. That's been about it, everyone. And this was the whole idea of this webinar, to give you a clear understanding of how multiple technologies are related and how they work in general. And how to plan your learning about machine learning, and how to plan your learning about deep learning as well, right? So many of these stuff we wanted to cover up in this webinar. So that's about from my side. Now we are open to questions, and other than that, we're also planning to have a similar training on the request of multiple students, in coming up, which is going to be more of Python with data science and machine learning as well. So it's going to cover up from the starting or basics of Python to uh, it's going to cover up basics of Python to Python for data science, in which we'll learn, or you can say Python for mainly data analytics, actually, to machine learning algorithms. Image processing, right? So the all the three fields we are planning to cover up. This is for mainly students who are not able to attend any internship at this point because of this corona pandemic. So and the working professionals from IT companies as well. And it just we have planned out a very less expensive, at the same time the course which kind of covers a live course like this webinar, which covers almost every segment to computer vision and natural language processing. You can also request for a detailed content of this as well to your point of contact, maybe to Ashish or any of us or Vaibhav as well, right? So we are planning to have a smaller course on this, which can give you a quick idea and clear understanding of many of these terms. In case you are looking to have any such learning material, you can look at the content and let us know your response on that for sure. So now we are open to questions. So let me know, everyone, put your questions, all of it in the chat box. Any questions, any doubt you have, we are good to go about that.